Alright, for this second video we're going to talk about Chapter 1, Lesson 2, Geographers and their tools. And we have been using some of those tools in class by looking at maps and figuring out latitude and longitude, so we're just going to investigate that a little bit further in the slides that we go through. So here are some of the learning targets. I want you to think about how geography has influenced the way people live. Same kind of first guiding question that we had on the first video. So remember, we already covered latitude. I'm not going to spend a lot more time going over this. We know that those lines are in east and west on the map. They measure north and south of the equator. Lines of longitude do the opposite. So this map here is showing the lines of longitude, even though it says latitude. Be aware of that. I want to go ahead and kind of move on here. Globes are the most accurate visual representation of the Earth because it is a sphere. It's round just like the Earth. It accurately represents the size. It doesn't distort the size of certain things. Bodies of water and continents are all the same size they are. Distances are accurately shown correctly. So it can be divided into 4 hemispheres or halves of the Earth. So there's kind of a couple ways of looking at hemispheres. So we have the northern hemisphere and the southern hemisphere, and then the eastern and western hemisphere. And when we talk about we cover the eastern hemisphere, so we cover both the northern and southern hemispheres. We're going to talk about places that are cold because they're really far south, such as Antarctica. We're going to talk about places that are very far north, like northern China, northern Russia. And then we're going to talk about places that are along the equator. So we're going to cover really northern and southern hemispheres, but only the eastern hemisphere we're going to focus on. Another type of visual representation of the Earth are maps because they are flat. Physical reality is distorted or shown incorrectly. So maps are not the best way to show the Earth as it really is, but a map is easy to carry. It can show parts of the Earth, or it can show the entire thing. It can show more specific detail of something than just what the Earth looks like. You might have maps that show population. You might have maps that show where resources are at. So it can do a lot of different things. It doesn't have to just show cities, countries, and so on. So maps can be very specialized. And they're also, I think I already said that they're easier to carry, but they're just smaller. A globe is kind of big, and can you imagine taking a family vacation and you take the family globe into the family maps to go places? I mean, most of the time anymore we're just using even our phones to navigate and leaving any kind of atlas probably at home. But maps certainly are easier to carry. Some parts of the map that you would need to know: there's usually a title that tells you the type of map that it's going to be and what area you're looking at. When we did the latitude and longitude, some people were looking at the wrong maps and then struggled to find the country that they needed to identify. The key explains the symbols, what the colors might mean, if they mean anything at all, and then lines used on the map. The scale bar tells us how a measured space on the map corresponds to actual distance on Earth. So just because your map is 3 feet wide doesn't necessarily mean it shows the same thing as another 3-foot wide map. Especially as places get more zoomed in, they're showing a smaller amount of land, so they may have a different scale with them. Some of the maps in my room show the entire world, so the scale used there is a lot different. So there's large scale maps that focus on smaller areas, and there's small scale maps that focus on large areas. There's also a compass rose that shows the cardinal directions with it. So here you can see, there's often the legend down in the corner. So pointing down here, it often tells you which way is north. All the parts are labeled. So this could even just be a city map. It doesn't have to be something that is showing an entire country. It could be a smaller scale map. Geographers use map projections to convert the round Earth to a flat map. A map projection distorts some aspects of Earth in order to represent other aspects as accurately as possible on a flat map. There are 4 major map projections. There's the Mercator projection, Goods interrupted projection, Robinson projection, and the Winkle-Trimble projection. So those are kind of four major types. And I kind of talk about each of those. This is what the Mercator map looks like. You can kind of see, especially up here, it distorts like Greenland. Look at Antarctica. It is huge. This is probably the biggest problem with this map. It looks like you could basically put, like, I don't know, half the continents inside of Antarctica. Antarctica is large, but it's not that big. And it really distorts those things at the poles more than anything else. Alright, so moving on, here is this next one. This may strike you as kind of odd, but think of this as like someone peeled an orange and then tried to kind of flatten it out. So you can see that the Earth is still kind of round, but it's been flattened out to try to fix how some of them are distorted. Notice that Antarctica is much smaller on this one, but its weakness is that reading the latitude and longitude is hard because some lines don't go all the way across, right? There's just space in between those. So geographers have tried many different tactics to try to make maps more accurate in certain ways. This one's we use a lot, the Robinson projection. This is maybe a similar type of maps in my room. It still also does distort. It kind of shows that spherical form, but it still does distort. And then the Winkle-Trimble, it does best to reduce the distortion, but it does also have some distortions around the pole. So the main problem with maps, even though you just looked at all these different types, is this distortion that happens, and that changes the size of those things. There are two major types of maps. That is general and thematic. General shows a wide range of information. So the political maps and physical maps that we've looked at recently, those are both types of general maps, and then thematic shows specialized information. So this video might be a good one to check out. This will be in the content website if you look at the slides. Political maps show human-made features like boundaries and borders of countries. That's what I really recommended when we did the worksheet on latitude and longitude, because you could see clearly what country you were in. So that's one of the main benefits of a political map. A physical map shows all physical landforms, and it especially allows you to see elevation. So even you can see, like up here, we can see that we're in the mountains up here, and down here, those are very mountainous regions in Asia. So it's great at showing elevation. Sometimes that is called relief. Thematic show specialized information. So here we've got highways, so those are being drawn out and shown. It can show just a variety of different information depending on the type of map that it might be. GIS is a geographic information system. Uses computer hardware and software to gather, sort, and analyze geographic information. So interesting enough, I had never really heard this term GIS until living in Monroe County. Monroe County has a GIS. I might actually have you Google that in class. I don't know if you'll be able to access the website, but you can use it to find pretty much any property in Monroe County, whether that's someone's house or something else. It's a little bit difficult to navigate, but you can search around. So if someone created that, and it's one of these geographic information systems. It's just a way to kind of telling different pieces of information, and it usually is layered, just like you see here. And you can take off those layers, think about like a layer of an onion, to be able to identify the different parts. Alright, so moving on, next part here. GPS is kind of the last thing I want to talk about in this video. Satellites orbit the Earth. Whenever you're using a GPS system, it triangulates the signal, meaning it catches on to 3 of the satellites, and that pinpoints your location. It was originally created by the military, but since now it's been used for lots of other purposes just by people. So I run, and my watch by GPS tracks my distance. People use it fishing, all kinds of things for outdoor uses. I have one that tracks my distance riding my bicycle, and it works by GPS. So GPS has gone far more beyond just navigating from places. Sometimes it can even track data. So GPS and GIS are both useful features that we use. Here is kind of a video that kind of tells you how this whole process works. Here you can see all these satellites orbiting the Earth. If you get some time sometime on a clear night, look up in the sky. If you see a star that looks like it's moving, most likely that probably is a satellite in the sky doing its job of orbiting the Earth. I'm not sure how many satellites are up there, but it's a lot. Probably several hundred satellites orbit the Earth. doing different things. Some of them are probably for television and things like that, but some of them are strictly kind of for GPS. So, a little bit about the tools used by geographers. I appreciate you watching, and I've had a little bit of problem with how this is set up, so I need to kind of